Okay, on to question 5. So, again, this is quite a big question. There's a big cone with loads of axes. Again, something people look at and think, don't really want to do this, don't know if I can do this. And it is very straightforward. Again, we're, the SQs have to try and dress up the same subject matter in different ways. Okay, and this is really just about, it's really just counting blocks. Actually, something that people have been doing from a very young age, but it's just dressed up in a different way. Okay, so we've got a cone, and the base of the cone has got a diameter of 6 units. Okay, diameter of 6, and it's got a height of 8. Okay, everything else, yeah, okay. X-axis, yeah, for base, yeah, we can see that on there. A is a point of contact, yeah, and B is directly above the centre, where that dotted line shows it. So again, everything they're kind of writing down, you can kind of see here. You see B is above that point. We can see that it touches the axis just once. It's so not really a lot in here. The diagram's doing quite a lot. Again, people that do these papers, they get paid a lot of money because they're very good, and they show everything they show is for a reason. Okay, they're not wasting their time. Okay, so they've done this deliberately to give you as much information as possible. All right. So write down the coordinates of A and B. So first of all, where is A and B? Well, there's A. I don't like the thickness of that. There we go. There's A, and there's B. Okay, so what information do we know? I'll mark this up in. Let's go for a nice red. Okay, so diameter of 6 for the base of the cone. Okay, so we know that from here to here is 6 units. Okay, so we know that is 6 units. Okay, now if it's a cone, it doesn't quite look like it, but it looks more kind of elliptical. But oops, that is going to be 6 as well, isn't it? Because that's just a circle. The angle here makes it look more elliptical, but if it's a cone, then yeah, this is going to be 6 and it's going to be 6 there. So that's probably the first thing that maybe people might get confused with and think, well, it doesn't look like a cone, but if it's a cone, that's a circle, and that's 6 and 6. Okay, the height is 8, so we know that from the base here, from the centre all the way up to here, it's going to be 8. Okay, so I just put that in there, oh, 8. That's 6 and 6. So again, mark these up on your exam paper if you want. Feel free to do so. That's fine. So yeah, but that's what we're talking about. Coordinates of A and coordinates of B. So a coordinate's got an X, a Y, and a Z. Okay, and we're looking for coordinate A, and we're looking for coordinate B. Okay, so that's all we're doing. We're just looking at how many blocks are we going to move along the X, the Y, and the Z. Okay, so I'm just going to rub out just to make it a wee bit clearer. Just this little bit in here. Okay, I'll just rub that out now we've found where they are. Okay, so for A, how far along the x-axis do we go to get to A? Well, we said that we're starting here and we're going along there, which is halfway, isn't it? The whole thing's 6, so halfway is going to be 3. Okay, nice and straightforward. Do we move on the y-axis? Is it anywhere up this way in the y-axis? Nope, so it's going to be 0. And is it anywhere on the z-axis? Nope, still 0. So we've gone along 3 and then we've stayed put. If it had a y number, it would be somewhere along here. If it had a z number, it'd be somewhere up there. Okay, and again, if you're getting familiar with your shapes, you'll know the z is usually the height of it, and this is on the base, so we don't have any height, do we, on the base? The base is right on the ground, so the z is going to be 0. Okay, but yeah, you can just see that as well. For B, so we know B is directly above the centre. So what is the centre point of this circle? Well, we're going along 3 and up 3, aren't we? Because the base of the circle is 6. Now, if we draw it in plan, it might make more sense. Okay, so if that's our axes, the circle's doing something like this, isn't it? So we go along 3 and up 3, yeah? Because that whole thing is 6 that way, and it's 6 that way, okay? So the centre of the circle has to be 3 along and 3 up. So it just looks a bit funny there. So we know that that's 3, and that's 3, and it actually tells us the height is 8, okay? So again, it shouldn't actually be too difficult to say, well, that's 8, but you can see physically you're going up 8 units, okay? So marking scheme, not much to do in that. You get a point for each of them, and that's about it. Okay. But yeah, don't get stressed when you see these questions. They're actually very straightforward. Very straightforward. Question 6. Solve the equation. Okay, so a lot of folk might look at this and think, well, I'm going to start factorising, which isn't wrong. It's technically what we are going to do, I suppose. But the thing to notice here, it does say one decimal place, okay? And that makes you think, well, probably won't be a simple factorisation, will it? Okay, but the minute you see a solve the equation, especially when it's the one decimal place, we're going to use our big equation. Okay, we're going to use the quadratic formula. Okay, we're going to use this. Okay, so let's just write that down first. So it's minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, now again, they give you this equation, so it's right away your first step is a freebie. Okay, you just have to know that we're going to use it. Okay, so don't again look at this and think, well, I'm stressed out. Try and remember when you're solving equations, it usually means factorising them, and because we've got one decimal place, well, you know it's not going to be a simple one. Okay, so if you've not used this at some point in the paper, go back to the question that you've missed out. That will probably be where it's used. Okay, it's going to get used at some point, more likely than not. So what are A, B, and C? I think it's good practice just to write them along the side to remind you. So there's our A, there's our B, and there's our C. Okay. So A is equal to 3, B is equal to 9, C is equal to minus 2. Okay. And then we're just going to sub in now. Actually, what some people do is just work out this bit first, which I think is quite a good idea. So just working out the discriminant first. Okay. So I think on the side it's quite good just say, okay, B squared minus 4ac, and that comes in handy in other parts of maths. So I quite like that method of just doing this bit first. Okay, so 9 squared minus 4ac, so it's 4 times, 4 times 3, 4ac times minus 2, and that's very important. Okay, so we've got 9 squared, so it's going to be 81, take away 4 times 3, which is 12, times minus 2, which is minus 24. Okay, 2 minuses make a positive, so we're going to add them together, so that's going to be 105. So we've got a positive discriminant, so we know we're going to have 2 real roots. Okay, so that's why it's good to do that. Okay, so that means when we come to this step, I think it makes it a bit easier just to sub in. Okay, so minus b, we've got our minus 9, plus or minus the square root of our discriminant, which is 105, divided by 2a, which is of course going to be 6. Okay, now you could write 2 times 3 in here if you want, because we are subbing in. It's up to you really. Okay, so at this point we're going to diverge. Okay, we're going to have minus 9 plus the square root of 105 divided by 6, and we're going to have minus 9 minus the square root of 105 divided by 6. I'm just going to put a little box around this, a little box around this just now as well. Okay, so that's going to be root 1, and that's going to be root 2. Okay, so on the calculator, minus 9 plus the square root of 105 divided by 6. I just put the top bit in a bracket, do minus 9 plus root 105, do that in a bracket, then divide by 6, just in case you might find your calculator, if you don't do that, does minus 9 and then it adds the root 105 divided by 6 as a separate bit, okay? So just watch, again, this is getting used to your calculator. I like to just do that, that's kind of how I roll with it. Where have we gone? A lot done there. Okay, don't know what I did there. Still some technical issues on the kit. So yeah, just make sure you do that right in your calculator. So effectively, what I'm saying is do this, in a bracket. Okay. So the first one I'm getting minus 9. I'm getting 0.207, 0.207, and for the second one, and again for the second one, you can keep everything the same in your calculator. Just change that positive to a minus, and that's going to give me minus 3.2. I'll just write down the 3208. I'm just going to keep the 3 decimal places. Okay, so in terms of marking, you're going to get a mark for substituting the formula correctly. So if we just didn't do this discriminant part, if we just did the next step here with putting everything in, you would get a mark. Okay, you actually get a mark for doing the discriminant. So in this method, we'll get a mark for that, and then we get a mark for this. Okay, but some people would just substitute everything in and then start to solve it down. But you do get a mark actually just for the discriminant, so it's worth. That's all you remember. It's 1 mark for not doing very much, and then for both of your final roots. So again, what we just worked out there. What we solved. This is the point when this quadratic is going to cross the x-axis. Okay, so I don't know what it's going to look like, but I do know that at -3 and at 0.2, okay, that's where this quadratic crosses the x-axis. So maybe it looks something like that. I don't know. Okay, but it's these 2 points we've just worked out. Now, you don't need to put that, but again, just thinking about what you've done, that's all this equation's doing. Okay, and it's because it's a complicated graph. If it was less complicated, if the numbers were nicer, we could have done it by hand, but that would probably be in the other paper. Okay, nice one.